Today we're going to talk a little bit more about image resolution. For the assignments in this class, I'm asking that your images be at least 300 dpi and at least 5 inches by 7 inches, which comes to about 1500 by 2100 pixels. So as you can see on my screen, I have seemingly the same image, but I want you to notice two things. Up here in the title, here it says this image is at 100%, and here it says this image is at 16.7. The image on the right, this is a high resolution image. The image on the right is a low resolution image, and I'm going to show you how you can tell. So selecting the low resolution image, I'm just going to go to Image, Image Size. If you look at image size, the first thing you need to look at is pixel dimensions, right? So I'm giving you guys the requirement that your images be either 1500 by 2100 pixels or 2100 pixels by 1500 pixels. As you can see, this only has 720 by 480, and it's at 72 pixels per inch. If I look over here at the high resolution image, you can see that the pixel dimensions are 2934 pixels by 4400 pixels, and the resolution is 300. Most students tend to look at this number first, which doesn't mean anything if these numbers aren't where they need to be. Let me explain a little bit further. Pixel dimensions basically talks about how much information is on or is in the image, right? Think about standard definition televisions versus high definition televisions. A 1080p television has 1920 by 1280 pixels. That means there's a lot more information than a standard definition TV, which only has 640 by 480 pixels. So obviously a high definition television is nice and crisp and clear. So I'm going to cancel out of here, and what I'm going to do is I'm going to zoom in on this model's eye. And when I do that, you can see that as I get closer, it starts to break up. Let's get rid of that right there. So you can see that the high resolution is still nice and crisp, whereas the low resolution image is starting to break up, right? What students tend to do is they find an image they like, and this one is, let's go back to the low resolution image, and they just change the size. So let's do that and see what happens. So image size, and I gave you guys a requirement of being at least 1500 by 2100. So that meets the requirement, and then they change this to 300 dots per inch. Oops, let's resize that. So there, by definition, this meets the requirements that I gave you for your assignments. But if I hit OK, let's go back to looking at them side by side. You can see that it resizes the image. However, the quality doesn't improve. That's because we're simply stretching the image out. So we're not actually making it a high resolution image, we're just stretching a low resolution image to the specifications I gave you. Let's go back. Now the other thing I want to discuss is another thing that students are doing is that they're scaling images disproportionately. And let me show you what that means. So here's my high resolution image, right? And what some students are doing is going to image size, and they're making the mistake of unchecking constrained proportions. You always want to keep that on. So if I turn that off and I force this image down to 1500 by 2100, you can see that it has stretched her out horizontally. So let's look at them side by side. So you can see it doesn't look quite right. So you never want to do that. Instead, let's start again. You want to go to image size, and since I'm saying that the minimum has to be 21 by 1500 pixels, just as long as they're close. Oops, Let's go back to constraint proportions, and I want to say there. So that has scaled the image right where I need it to be. This ensures that if you take a recognizable image like a picture of a model and scale it disproportionately, it makes it look more unnatural and therefore less believable. So we want to avoid that at all costs.